We're finally back with part 2. This is a budget, open source toolchanger 3D printer based on a Sovol SV08. Yes, I know, it has been way too long since I released part 1, but progress has been made. There's a lot to cover, so let's jump right in. First things first, this is part 2 in a series on building up a custom toolchanger based on a Sovol SV08. Part 1 explains the project in more detail and has an upgrade of the power supply. Just because Sovol sent me this printer for free so I could make this series doesn't mean I'm going to give them a free pass. So let's start with some viewer feedback. Firstly, one of the reasons I went for this printer as the base was because it's meant to be open source, and it is on GitHub, including all the step files which I've been able to import into Onshape and has made my life easy, plus pinouts for the mainboard and toolhead which has made life easy too. But that doesn't mean the open source aspect is perfect, as we can see in GitHub issue number 8. R6C has commented that there's some instances where the GPL license has not been respected, so I would like to add my weight to the argument by agreeing that Sovol should fix this and respect the license fully. Secondly, there was a few comments on the first video saying that they had been waiting for their printer for a while and they were upset that I had jumped the queue. Looking back at the screen recordings from the first video, I can see that the printer wasn't meant to be delivered to anyone yet. But I was completely oblivious to this, so I apologise to all of those who I cut in front of. All I can say is that I hope the work I put on in this project redeems me in the long run. I was hoping by now that everyone would have their printers, but then I got this email from viewer Vikram. Let me know in the comments if your experience matched this, but it seems like customers who pre-ordered were pushed down the priority list for those purchasing later on Amazon. Last week, they sent out this generic email claiming that printers would ship within 12 hours. So if you're still waiting for yours, please let me know in the comments and I'm happy to apply pressure to them directly. Next, let's address the elephant in the room. Why so long between part 1 and now part 2? Well, part of it is just being busy, but there is a lot more to it than that. Not long after the first video, I had a video call with 3 of the members of DraftShift Design, authors of the StealthChanger and co-collaborators in this project. This allowed us to look at the SV08 in more detail, with me sharing elements of the machine over the webcam feed, and also for us to come up with a plan of attack. This was useful, but there was one main thing getting in our way. The SV08 is a self-proclaimed clone of a Voron version 2. But here's the thing, I was the only one with an SV08, the DraftShift team had no access, and conversely, I had never built a Voron V2, so I was very unfamiliar with it. So when designing, they had a CAD model they could go off, but no way to verify things in real life. And for me, it's overwhelming looking at all the options that their system supports, especially when I import the CAD to find that there's multiple variations, none of which I'm familiar with. It just makes things a lot harder and slower when both sides of the collaboration have limitations in either their access or understanding. Another big reason for the delay was ordering parts. We had to work out exactly what I needed, and then I had to wait for some to come from China over AliExpress. Other things like the magnets I had to source locally, so that added a bit of complexity, and some of the stock took a little while to come. And after all of that, of course, we need time just to actually design and test the parts. Everyone involved is busy and we're doing it on top of other things. Just quickly, a word on the build philosophy, especially in terms of StealthChanger doing a great job by being compatible with multiple toolheads. My aim for this build is to do things as simply and cheaply as possible. That means using additional SV08 toolheads because it keeps things like the firmware and wiring more simple. And of course, if people want to go a different direction, they'll be able to. It's completely their choice, and choice is a good thing. But just keep in mind, it does take a little bit longer to design parts that can be fitted to the machine, yet don't alter it permanently. It's my aim to make this build scalable for as many toolheads as you can fit, but also for the most part reversible back to standard spec. I am sorry it's been so long, but better late than never. Let's press on. We start by talking about this front extrusion. We can see on this video by Hedgehog Makes that we need a place to attach the docks to hold the tools that aren't being used, and this attaches to the 2020 extrusion on a Voron V2. But the SV08 has these custom extrusions and there's nowhere to attach the docks. Under the StealthChanger, if we look in user mods and come to the SIN, we can see there's an SV08 dock bar brackets. And inside we have a simple part for adapting some 2020 extrusion. This has been the basis for a number of remixes, including this one by Richard Farrington, which I printed for my build. You'll need a piece of 2020 extrusion trimmed down to 421mm in length. At the back of the original front extrusion, there's M3 bolts, 2 on each side. One side also has the LED bar, which will need to be unplugged as you proceed. You don't actually need to completely remove this, but I'm doing so for clarity. The factory LED light bar will be in the way, so that also needs to be unscrewed from the extrusion. We can now take our 2 printed adapters and slot them into either end of our 2020. The original extrusion is just resting here with the bolts removed, and we offer up the new assembly from the back and then insert some M3 by 8mm bolts to go through into the original threads. When everything's done up, this is going to be pretty stealthy, with the piece of 2020 mostly hidden behind the factory piece. For now, I've added some T-nuts to the factory LED bar, and it's currently reinstalled in the bottom of the 2020, but I think it will be in the way and need a new home later on. So on to adding tool heads, which is probably one of the biggest jobs, and previously I speculated incorrectly that this printer uses CAN bus when instead it uses USB. This can be seen in the Klipper config, but is also clearly labelled on the diagrams on their GitHub. Each tool board has 24 volts and ground, and then 2 USB data pins with an extra ground in the middle. So let's experiment and try and get Klipper to talk to a second tool head. I started by taking 24 volts directly from the power supply, crimping on the appropriate JST connector, plugging this into a spare tool board which powered it up successfully. The main board has a spare USB port on the inside, so I Frankensteined up an abomination of a USB cable that utilized 2 data pins and the ground, terminated at the other end in another JST connector. Ignore the colors here, this is a temporary plug, just know that the pins are matched to the tool head already installed on the printer. I then plugged the USB cable into the main board and connected to the main board via SSH. What you're seeing here was an excellent moment where the additional tool board was picked up in SSH, confirming that it was in communication with the main board. After some quick and dirty modification of printer.cfg, I was able to add the second tool head to Klipper, report on its temperatures, and control things like the part cooling fan and hot end temperature. I then scaled up this proof of concept by introducing a crappy USB hub, and with it and some more temporary wiring, I was able to get the third tool head connected and under control. For me, this was a really important milestone, so now what we have to do is recreate it properly. The first piece was a recommendation from the Draft Shift guys, who said I should use this isolated USB hub rather than a standard one, so I ordered it and waited for it to come. Now to come up with a routing plan, with the factory loom coming out the bottom up to the back of the flying gantry, where it's clipped in place before then arching over to the factory tool head. If we represent it in a diagram, it looks something like this, and adding another 4 or more of these is going to get messy fast. So the plan instead is to run the cable up and over the very back of the machine and down to the tool head. This will be true for the original tool head wiring, but also the wiring for any additional tool heads, which means we're going to put the USB hub at the top rear of the frame as well. The original tool head cable is coupled together with some other wires that go to the flying gantry, so the first job is to separate it. This is a bit of a pain because it's sheathed and cable tied most of the way along, so all of this needs to come undone. There's also this little plastic cable management clip that needs to be removed by squeezing the legs together and pushing from the underside, but honestly this thing is a massive pain. Once we've turned off the printer and disconnected the first tool head plug from the main board, we can feed it back through and isolate it. Following this, we can feed it over the rear frame of the printer, through that original hole into the enclosure, and bring it back up to the main board. But our new wiring path is longer than the old one, so we're going to have to extend this cable. If you're unsure about wiring and crimping, I've got a coverall guide that goes through all of the tools and techniques you need, linked in the description below. To get a nice arch at the top without any strain, you're going to want to add around ½ a meter to this cable. For me, this was simply a matter of finding some spare wire with matching gauge and then soldering the new to the old. After that, I insulated the join with heat shrink, but further steps are a good idea to make this reliable. You'll notice that the original cable was 5-core and had some shielding to prevent interference. I can't recreate this exactly, but I did have some aluminium tape as a substitute. I cut a long length of this and wrapped it all around my extension, followed by some tape. As for terminating our extension, we need to match the connectors present on the original. This image and diagram should let you get the pins in the correct location and the correct connector. The bigger JST XH on the left hand side for power, and the smaller JST PH on the right hand side for USB data. You might have noticed that the factory connectors use hot glue, mainly to stop the connectors from coming undone by accident, but also for a bit of strain relief. So for this build, I'm trialing liquid electrical tape. This stuff is more like flexible silicone, so it's a nicer option than hot glue. For all of these plugs, I'm coating between the wires and the plastic connector. This stuff sets in 5 minutes and should stop the wires from wiggling and therefore snapping. With this finished extension in place, there should be plenty of spare cable to keep a nice arch when the tool head is in its furthest position, which is in the front corner of the bed. If you don't want to extend, an alternative is to purchase some new 5-core cable and run it all the way from the main board up to the original tool head. So that's the original cable extended, but now we need to install the USB isolator hub. I was keen for a printed mount that slid onto the factory extrusion and prototyped it with this skinny version. I then expanded the design, and this is how it currently works. There's a number of holes on the main piece that require M3 heat inserts. You can melt these in with a soldering iron, or like me, use a specialist tool like the one from Naomi Wu. Now we can undo the bolts for the top rear extrusion, removing them completely on one side but just loosening them on the other. This should allow the frame just enough flex to move the rear extrusion out of the way and slide on the printed base. I included some raised mounting bosses, and we use M3 hardware to screw into these, with the thread being cut the first time they're inserted. Let's connect up the hub by plugging in a USB cable to the spare USB port, and then feeding this through the opening in the lower housing. It's tight, but trust me, it will go through. The cable then connects to the hub at the other end. We need to provide the hub with 5 volts to the green terminal on the side. For me, the polarity was neither labelled nor documented, so I used a multimeter to confirm, and then labelled the negative terminal with a Sharpie. This is a low amperage 5 volts that we can take directly from the main board, in my case using the 2 left-hand pins from expansion port 1. I used a 2-core cable, approximately 1 meter in length, and crimped on a DuPont connector to suit. It's routed the same way as the USB cable, and at the other end is terminated with ferrules. You can now get your multimeter and test that 5 volts is present at the terminals. So now we've got USB up to the hub, but we still need 24 volts from the power supply to each tool head. For this, I'm using this 2-core auto cable. It's rated for 7.5 amps, which is way more than enough. I measured out 4 identical lengths of this. It was a bit short the first time, so I would recommend aiming for something like 2.2 meters at a minimum. Just to simplify things, I crimped on spade terminals in parallel pairs. This was ideal because there was a pair of positive and negative output terminals available on the power supply. A reminder that this is not the standard power supply, and that was replaced in part 1. That cable opening is getting tight, but there is room to fit through 4 of these cables. Alternatively, you could run one big set of cables up to the USB hub and split it into 4 from there. As for the other end of the cables, they need to be terminated with JST XH connectors. I'll have a diagram on screen to show the exact polarity shortly. The rear cover for the USB hub mount has these channels in it to mount each of the 5 looms, including the cable we extended to the original tool head. And once they're all roughly in place, we have this printed slide-on retainer that comes down and keeps them there. 6 M3x30mm bolts are used to keep the cover in place and the cables tidy. That rear cover and the wire clamp each have some false holes that need to be pushed through with a 3mm drill bit. This piece can then be loosely installed on the front side of the printed mount. We have our 24-volt cables ready, so let's finish by making a USB cable for each tool board. I started with 1.8 meter length USB cables, lined them up with the 24-volt cables, and then cut the USB cable in half to match. This left them with a length of approximately 1.1 meters. Now we need to strip back around 30 or 40 millimeters of the USB cable insulation. There'll be a bunch of shielding material inside that we need to peel back, move aside, and then trim much shorter. We also need to separate and trim the red 5-volt wire as we won't be needing it. We now want to fold these down towards the end of the cable and slide down some heat shrink, taking care to keep the 5-volt wire away from the shielding. Activating the heat shrink should keep it there. For the remaining 3 wires, we need to crimp on some JST PH connectors. Let's fast forward to an image where these are plugged into the toolboard so we can see the correct orientation of each color. Basically, it matches what we did earlier on the main board end. Before we connect the new tool heads, we need to prep them. The extra part cooling fan at the back will be in the way, so we need to undo the 2 M3 bolts and remove it. This will also entail cutting some small cable ties before finally unplugging it from the toolboard. On the upper left we have a cable clamp, and we need to remove these 2 screws completely. I've designed this very simple printed piece to go between the factory clamp and the rest of the tool head. and it should be thin enough to keep using the standard M3 bolts. Here's an unobstructed view of how it needs to sit when it's in place. We can now go ahead and plug in our two new cables, 2-pin 24 volts and ground and 3-pin USB. These cables will then tuck around behind before we put in our new printed piece, followed by the factory clamp. This is a little bit fiddly, but ultimately quite doable. Time to introduce the piano wire, which was recommended by the Draft Shift guys. The stuff I got was just under 1mm, and this equivalent on Amazon should do the trick. This stuff is a good mix between rigid and flexible, and it's going to hold our cables up out of the way. Back up to the USB hub mount, and there should be little slots at the front where you can feed the end in. In fact, there's slots for 5 of them, so you can run a piece of piano wire to the original tool head as well. We now need to trim the piano wire to length. You need to line everything up, and it's going to be slightly different for each installation, but mine ended up being approximately 1 meter in length. It's pretty difficult to cut, so wear safety glasses in case it goes flying after it finally gives way. We can now loosen the cable clamp retaining bolts, slide the piano wire in until it hits the stop at the bottom, and then tighten the 2 bolts up to keep everything locked into position. To finish, some 6mm self-closing braided wrap. Again, your length will vary, but mine ended up being approximately 1 meter long. We wrap this around the 2 new cables as well as the piano wire, and following this we can put back on the front cover for each tool head. Repeat for as many tool heads as you need, and everything will be wired up. I updated the design for the terminal power supply cover to have this slot in the side for the 24 volt cables to pass through, and I also designed this little grommet to be printed in TPU so these cables don't rub on the metal shield. It's a little bit tighter, but this electronics cover should still fit back on. We've got our 24 volt cables, our USB cable, our extended toolhead cable, and our 5 volts up to the USB hub. I want to finish by briefly covering my initial work in setting up Klipper. Before we turn the printer on, for each of our new additional tool heads, we want to temporarily unplug the USB connector we just installed, but we will leave the 24 volt connector in. We can now switch the power on and see that each of the new tool boards should be lit up with a blue LED. You'll see that the heatsink fans are spinning, and that's completely normal. If we look at the default printer config for the SV08, we can see that the serial address is quite generic, and that's the first thing we need to change. We now need to log in via SSH with the default username and password both being Sovol. We're now going to run ls/dev/serial/by-id*, and this should show 2 separate serial addresses. We'll now unplug the USB connector on the original toolhead. If we run the same command again, we'll see that there's now only one address, and this is the address that we need for our main MCU. So we can come to our config and replace what was already there with this exact address. Coming back to the terminal, the second address therefore is the one for our primary toolhead, the one that came with the printer. So we can paste this in place for that as well. Klipper will complain that it's lost connection with the MCU, but if we plug it back in, save the printer config and restart, everything should go back to normal. Now we do some future proofing and organization. Back in our printer config, we're going to do a search and replace for extra_MCU and replace it with tool 0. We'll now come through the config, copying everything that has a reference to tool 0, pasting it into a separate document. The only exceptions are the ADXL 1345 section and the probe section. Apart from that, if it says tool 0, we're going to transfer it over. Once everything's been copied, on the new document we do another find and replace, this time replacing tool 0 with tool 1. Because all the tool boards are the same, all of the pins will be the same too, meaning no further setup. However, there are some other small changes as some of these sensor names will clash, so we need to change them to toolhead 1, extruder 1 and so forth. Our final thing we need to fix is the serial address for the second toolhead, which is called tool 1. We plug in the USB connector for that one and run our list by serial once more. There'll now be 3 addresses and we need to copy and paste the new one, overriding the duplicate that we created earlier. If you hadn't guessed, we're going to copy all of the contents of this into another new file, this time doing a replacement from tool 1 to tool 2, and also changing the names from toolhead 1 to toolhead 2, extruder 2 and so forth. We can then plug in the next toolhead's USB, run the same command, and now there should be 4. The order of the addresses may change, so it's important to actually look for a new and unique one, and once we find it, we overwrite the duplicated one in the new config file. We're going to repeat this up to a file for tool 4, and we can see here we have the original, and then tools 1 through 4. Finally, back in our printer config, up the top we need to include each of these 4 new files, before we finally click save and restart and hope that they all show up. And if you have any luck, you'll be able to see tools 0 through to 4, or as many as you've added. And back on the dashboard, you'll have control for each of them, as well as seeing all of their temperatures on the graph. This is all well and good, but it's just the start. There'll be more refinements, but the main problem is Klipper doesn't actually have support for tool changes by default, which is why DraftShift are working on a Klipper add-on to support tool changing, which is based on that from the toolchanger. Once that is complete, it will be installed and handle which is the active tool, therefore telling the firmware which probe to listen to, which fans to turn on and off, etc. I still haven't published my files because there's still more work to do. For instance, I need to design something that holds these cables out of the way underneath. I'd like to tweak this USB hub holder to get everything closer together and more compact. We need mounting for an additional 4 filament spools in a way that won't get tangled. And I need to design a replacement for this cable management piece to suit all of the new wires. Most importantly, the specific parts for the tool changing operation need the design finished before they're printed, tested and refined further. There's still a lot to come, including documenting everything in step-by-step detail. Checking in on our running total, we still have a huge amount of headroom, which is very encouraging. As always, give me your feedback down below in the comment section. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.